couple videos, we were looking at molarity and using molarity to calculate the concentration of a solution. Now we're going to look at the last little equation in reference to solutions. It's for a dilution. Dilutions involve changing the concentration of an existing solution. So I already have a solution, I already know its molarity, and maybe I want to either add more water or I remove water and I change the concentration. It could look like this. M1V1 equals M2V2, where M1 and V1 are your initial molarity and your initial volume. M2, V2 refer to your final solution, the final concentration, the final molarity, and the final volume. We can do some really simple calculations that look like number one, how many milliliters of 12 molar hydrochloric acid would you need to prepare 500 milliliters of a 6 molar hydrochloric acid solution? And this is a really easy equation to use. It's just plug and chug. How many milliliters of 12 molar solution, HCl? That 12 molar, that's like our initial solution. That's our M1. So I could plug that in as M1, 12 molar. I'm trying to figure out what volume of this first concentrated solution I need to prepare 500 milliliters of a less concentrated solution. I want it to go from 12 molar to 6 molar. And now, with this equation, your V volume, it really can be liters or milliliters. What a treat. Molarity has to be moles per liter. This one, as long as M1 and V1 and V2, as long as the two volumes are the same unit, it doesn't matter which. They can be liters or milliliters. For now, I think I'll just plug this in as V1. It says how many milliliters, which is going to be my initial volume. How much volume of that 12 molar should I use if I want to prepare M2? I want it to be 6 molar. And then V2, I want 500 milliliters. Cool. All right, so I'm going to plug this in. We'll do some algebra. Into my calculator, I'm going to go 6 times 500 divided by 12. And I get something that looks like V1 equals 250, and that would be milliliters. If my V2 was milliliters, my V1 is milliliters. Okay, so you plug in your calculator. It's an easy equation. It's plug and chug. And now you just say, great, I'm moving on. But actually, this kind of makes sense. So technically, this is volume of the original 12 molar HCl. Well, in the end, I want 500 milliliters of solution. Where's the rest of the volume? I mean, here I calculated 250, but where's the other 250 coming from? I bet you guessed it. Water! We're going to use water to dilute the original solution. So then you'd also use 250 milliliters of probably distilled water. So that together you get the total 500 milliliters of solution. Now this particular calculation is great. It makes total sense. I want to cut that concentration by half. I want to go from 12 molar to 6 molar. So it totally makes sense then that half your new solution ends up being the original HCl, and then to cut the concentration by half, the other half of the solution is water. Totally makes sense. And then we get a total combined volume of 500, our desired volume. Great little equation, super easy to use. And we can flip this around a couple ways. Like we can solve for a volume, we can solve for a new molarity, like in number 2. 100 milliliters of water are added to 500 milliliters of a 1 molar silver nitrate solution. What is the new concentration? Okay, so M1V1, that's my initial solution. Initially, I had a 1 molar silver nitrate solution. So let me plug that in, 1 molar. That's like my M1. V1 is the initial volume, 500 milliliters. Initially, I had 500 milliliters of a 1 molar solution. M2 is the new molarity, which is what I'm trying to figure out. I want to know the new concentration. So M2 will be my variable. V2 is the new volume. So here's where I just have to be a little bit careful. 100 milliliters of water are added to 500 milliliters of the original solution. The final volume is not 100. The final volume is 600, right? So here, like, we have to add the two. It's 100 milliliters of water and 500 milliliters of the original solution for a total volume of 600. The same would be said if they were like, yeah, you started with 500 milliliters of this solution, and maybe somebody put it on a hot plate and they evaporated 100 milliliters. If they removed 100 milliliters of water, well, now the final volume, V2, would end up being 400. Piece of cake. Plug it in. 1 times 500 divided by 600. M2 in my calculator is about I'm going to say 0.83. And now this makes sense. If we think about the equation for molarity, molarity equals moles per liter. Well, when we're doing a dilution, when we're changing the volume of a solution, we're either adding water, or again, we could let a beaker sit out for a period of time and maybe water would evaporate, or I put it on a hot plate and water evaporates. The moles of solute never changes. Never changes. We don't change the moles. So if this was silver nitrate or sodium chloride or whatever it might be, whether I add water or I remove water, that doesn't change the amount of solute. There's still the same amount of silver and nitrate in that beaker. You've just added more water. So the moles stays constant. But now this makes sense. So I started with 1 molar. I added water. The concentration is less. Now it's like 0.8. Well, yeah, because this guy on the bottom is what I can change. I added more water, which means I increased the value in the denominator, but I kept the moles the same. So if I increase the denominator, it makes sense then that the molarity should be a smaller value. And it just makes sense in concept too, that if I add more water, something should become less concentrated. When we do this in the lab, we're going to use a solution that's colored so that we can see as we add more water, it becomes less concentrated. The molarity will become smaller. It's going to be the same amount of ions, whether it's silver nitrate or nickel nitrate or copper nitrate or whatever it is. But by adding more water, it just becomes more dilute. The molarity is smaller. Now, on the flip side, if I were to remove water, then this number in the denominator becomes smaller. So if I remove water, then the solution becomes more concentrated. It's the same moles, but in less solution. That's just great. All right, so we can solve for a volume, we can solve for molarity, we can solve for something initial, we can solve for something final. And finally, we can explain how to make a diluted solution. And number 3, explain how you would dilute a 6 molar sodium chloride solution to 100 milliliters of a 2 molar solution. And again, this is pretty typical, that if I want to make a dilution, I probably know what I'm starting with. I know my M1. My initial solution is 6 molar, but we usually just don't know what to use. I should say how much to use. I go in the stock room and I want to make a 2 molar sodium chloride solution. Well, I could start with something more concentrated and then just add water. We do it all the time. When I buy my acids, I buy them as concentrated as I can get. It's better value. I'll buy the concentrated acid, but we don't rarely use it concentrated. I usually dilute it. We add water. We know what we want, though. I want a 2 molar solution, M2V2. And I know the volume that I want, 100 milliliters. Sweet. So often we're solving for the volume of the original concentrated solution. So I'm going to plug this in as 2 times 100 divided by 6. And V1 is a big fat, I'm going to say 33.3. It's like 333 repeating. Now, technically, again, that calculation is a piece of cake, but I have to know what that number means. That's milliliters of the original 6 molar sodium chloride. And again, milliliters is fine. The other volume is milliliters, so I can use milliliters here too. All right, so here's how I make the dilution. We're making 100 milliliters, which would fit in a standard, like, graduated cylinder. And so I might say something like 1. Measure the 33.3 milliliters of 6 molar sodium chloride using a 100 milliliter graduated cylinder. Graduated cylinder. These are those larger ones that you have in your drawers. So we'd measure 33.3 milliliters of the original solution the best I can. So it might look something like this. Here's my graduated cylinder. And the bottom, maybe like this here, is like 33.3 milliliters. And that's going to be the 6 molar, yikes, sodium chloride. Okay, so there it is. I put that in the beaker first. Graduated cylinder. And then piece of cake. In step 2, we're just going to add distilled water. Until my desired volume. Here I want 100 milliliters total volume. And then obviously we would stir, somehow mix the two. I don't usually measure the water. I would measure the amount of the original solution, and then I just squirt water in until I hit, let's say this is 100 milliliters. Total. And so then I'd fill the rest of this with water. So that's going to be my water. And then I get my combined volume, 100 milliliters. Now, in reality, this would end up being about, let's see, 100 minus 33.3. This is going to end up being about 6 67.7 milliliters of water. So that the water plus the other solution will give you your total combined volume. I just don't usually go out of my way to measure 67.7. I just use a graduated cylinder that I know has a marking for my final volume, and I try to use a graduated cylinder that is as detailed as possible so I can get the 1/10 of a milliliter measured. I measure the first solution precisely and then just squirt water in until I get my final desired volume.